40 kilometers east of Moscow, at the Central Air Force Museum in Menino, there sits a machine that defies comprehension. From a distance, it looks like an aircraft that has swallowed another aircraft. A metal leviathan whose wings extend outward like the arms of some Soviet titan frozen mid-embrace. The paint has faded. The rotors no longer turn. But even in silence, even in rust, the V-12 commands the kind of reverence reserved for cathedrals and battleships. It remains, more than half a century after its creation, the largest helicopter ever built. No nation has surpassed it. No engineer has dared attempt it again. And it was designed for one purpose that humanity would rather forget: to carry nuclear annihilation across the Siberian wilderness. The story of the V-12 begins in the paranoid geometry of the Cold War. By the late 1950s, both superpowers had developed intercontinental ballistic missiles capable of reaching any target on Earth within 30 minutes. The Americans had their Atlas and Titan rockets. The Soviets had their own expanding arsenal. But there was a problem that haunted Soviet military planners. These missiles were enormous. The first generation of Soviet intercontinental ballistic missiles weighed dozens of tons and required elaborate launch facilities, and launch facilities could be found. In 1956, American U-2 spy planes began crisscrossing Soviet airspace at altitudes exceeding 70,000 feet, photographing military installations with impunity. The Soviets tracked these phantom aircraft on radar, but could not reach them. Each photograph revealed another secret: bomber bases, submarine pens, and most critically, the railroad networks that transported missiles to their launch sites. A network of rails leading to a remote location in Siberia was not a mystery. It was a target. The solution seemed almost absurd in its ambition. What if the missiles could be moved without rails? What if they could be delivered to launch sites so remote, so inaccessible, that no road could reach them and no satellite could anticipate them? What if the Soviet Union could hide its nuclear deterrent in the trackless wilderness of its own territory? The answer was a helicopter of impossible scale. In 1959, preliminary design studies began at the Mil Moscow helicopter plant under the direction of Mikhail Emil, already the most celebrated helicopter engineer in Soviet history. Mil had been born in Irkutsk in 1909, the son of a railway worker. At age 12, he won a model glider competition. By his 40s, he had created the first mass-produced Soviet helicopter, the Mi-1. His Mi-6 had become the largest helicopter in the world, capable of lifting 12 tons. But the military demanded something far greater. They wanted a rotary-wing aircraft that could lift 22 to 28 tons. They wanted a helicopter with the cargo capacity of the Antonov An-22 strategic airlifter. They wanted to carry intercontinental ballistic missiles through the air. The engineering challenges were staggering. A conventional helicopter design simply could not be scaled to such dimensions. A single rotor large enough to lift the required payload would have exceeded structural limits and created aerodynamic instabilities that no technology of the era could control. Mil and his team explored tandem rotor configurations similar to the American Boeing Chinook. They considered coaxial designs. Nothing worked at the required scale. Finally, they settled on a transverse rotor layout, a configuration that had been used in smaller helicopters dating back to the German Focke-Wulf FW-61 of the 1930s, but never at this magnitude. Two complete rotor systems, each borrowed from the proven Mi-6, would be mounted at the tips of enormous, inverted, tapered wings extending outward from a central fuselage. The numbers alone stagger the imagination. The V-12 measured 37 meters in length, longer than a Boeing 737 airliner. Its wingspan, measured from rotor tip to rotor tip, reached 67 meters, nearly 220 feet. It stood 12.5 meters tall. Empty, it weighed 69,100 kilograms, more than 152,000 pounds. Fully loaded, the maximum takeoff weight approached 105,000 kilograms, more than 231,000 pounds. It was as heavy as 9 Mi-24 Hind gunships combined. Power came from 4 Soloviev D-25VF turboshaft engines, each producing 6,500 shaft horsepower, for a combined output of 26,000 horsepower. These engines drove 2 5-bladed main rotors, each measuring 35 meters in diameter. The cargo bay measured 28 meters long by 4.4 meters wide and 4.4 meters tall, large enough to accommodate city buses, armored vehicles, or the components of intercontinental ballistic missiles that had justified the entire project. Construction of the first prototype began at the Mil Experimental Facility in Panki in 1965. On the 27th of June 1967, test pilot Gurgen Karapetyan attempted the first flight. It ended in seconds. Oscillations caused by a harmonic amplification of vibrations through the cockpit floor fed back into the control column, causing the helicopter to lurch violently. One set of main wheels struck the ground hard, bursting a tire and bending a wheel hub. Western intelligence reported, erroneously, that the aircraft had been destroyed. It had not. The engineers traced the problem, corrected it, and prepared for another attempt. On the 10th of July, 1968, the V-12 lifted from the factory pad and flew to the test facility in Lyubertsy. The largest helicopter in human history had taken flight. Karapetyan, who would later become a hero of the Soviet Union, reported that the aircraft handled remarkably well for its size. The transverse rotor configuration provided stability that would have been impossible with a single rotor system. The records came quickly. In February 1969, the V-12 lifted a payload of 31,030 kilograms to an altitude of 2,951 meters. On the 6th of August 1969, it lifted 44,205 kilograms, more than 88,000 pounds, to 2,255 meters. These records remain unbroken. No helicopter has ever lifted more weight to altitude. The Fédération Aéronautique Internationale certified the achievements. The American Helicopter Society awarded the Mil design team its prestigious Sikorsky Prize for outstanding achievements in helicopter technology. The irony was exquisite. A Soviet helicopter designed to deliver nuclear weapons against America was honored with an award named for Igor Sikorsky, the Russian émigré who had founded the American helicopter industry after fleeing the Bolshevik Revolution. In May and June of 1971, the first prototype flew across Europe and appeared at the 29th Paris Air Show at Le Bourget, wearing exhibit code H833. Western observers were stunned. NATO intelligence analysts assigned it the codename Homer. They speculated about its potential as a tactical airlifter, capable of delivering armored vehicles to support heliborne assaults anywhere in the world. What they did not know was that the V-12 was already obsolete. The mission that had justified its existence had evaporated while the helicopter was still in development. On the 1st of May, 1960, Soviet air defenses finally shot down an American U-2 over Sverdlovsk. Pilot Francis Gary Powers survived and was captured. President Dwight Eisenhower immediately halted all overflights of Soviet territory. But the Americans had already developed something far more effective. 3 months after the U-2 incident, in August 1960, a Corona satellite called Discoverer 14 returned photographic coverage of the Soviet Union that exceeded all previous U-2 missions combined. The era of satellite reconnaissance had begun. Within a few years, American satellites could survey 7 million square nautical miles per mission. They could photograph every corner of the Soviet Union from orbit. The wilderness was no longer a hiding place. Remote launch sites could be discovered regardless of whether they were connected by rail or road. The fundamental premise of the V-12, that missiles could be hidden from American eyes by transporting them to inaccessible locations, was rendered meaningless. Simultaneously, missile technology evolved. Intercontinental ballistic missiles became smaller and lighter. New generations could be transported on trucks rather than requiring dedicated rail infrastructure. Multiple independently targetable re-entry vehicle technology allowed a single missile to carry numerous warheads, vastly increasing firepower while reducing the number of launch sites required. The heavy, cumbersome missiles that had necessitated the V-12 were being replaced by weapons that no longer needed it. Mikhail Mill died on the 31st of January 1970 before witnessing the cancellation of his greatest creation. He was 60 years old. The Sikorsky Prize was awarded posthumously in 1971. A second V-12 prototype was completed and flew in March 1973, but the Soviet Air Force refused to accept the helicopter for state acceptance trials. The program was officially canceled in 1974. Only 2 aircraft were ever built. Proposals emerged to convert the V-12 for civilian use. Aeroflot considered a passenger version capable of carrying 196 people, as many as a modern narrow-body airliner. Engineers suggested using the helicopter for mining and logging operations in remote Siberia, precisely the terrain it had been designed to serve. None of these proposals materialized. The operating costs were prohibitive. The infrastructure required to support such a massive machine did not exist. The technology that had made the V-12 possible had been rendered pointless by the technology that made it unnecessary. The Soviet military eventually adopted the Mi-26 in 1983 to fulfill its heavy lift requirements. The Mi-26 was smaller than the V-12, but still the largest production helicopter ever built, capable of lifting 20 tons. It remains in service today. It proved that the Soviets could build excellent heavy-lift helicopters. They simply could not justify building one as large as the V-12. Today, the 2 V-12 prototypes survive as museum pieces. The first remains at the MIL Moscow helicopter plant in Panki Tomilino, fading quietly in the shadow of the factory that created it. The second stands at the Central Air Force Museum in Manino, where visitors can walk beneath its enormous wings and contemplate the audacity of its creators. There is something profoundly melancholy about the V-12, something that transcends the usual narratives of technological obsolescence. It was not a failure of engineering. The helicopter worked. It exceeded its design specifications. It set records that stand more than 50 years later. It won international recognition from the very nation it was designed to threaten. The failure was one of timing and circumstance. The world changed faster than the machine could be built. The V-12 was conceived to win a shadow war that had already shifted to new battlegrounds. By the time it flew, the skies had been replaced by orbit. The wilderness had been replaced by transparency. The nuclear chess match had evolved beyond the need for helicopter-delivered missiles. Everything the V-12 represented, the scale, the ambition, the paranoid logic of mutually assured destruction, belonged to an era that was already ending. Standing beneath those silent rotors at Monino, one cannot help but wonder what world would have required such a machine. A world where nuclear weapons traveled by helicopter, across frozen tundra to hidden silos. A world where concealment was still possible. A world before satellites stripped away the last illusions of secrecy. The V-12 is a monument to that world, to its fears and its technologies, to the lengths that nations would go to ensure their capacity for annihilation could not be preempted. It remains the largest helicopter ever built, a record that will likely stand forever. Not because we cannot build bigger, but because we no longer need to. The mission has vanished. The enemy has dissolved. The Cold War ended, leaving only its artifacts behind. Among them, rusting quietly in a Russian museum, stands the Titan that was built to carry the apocalypse and never had to.